Welcome to AI for Good, the leading, action-oriented, global and inclusive United Nations platform on AI. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with 50+ UN, sister organizations and co-convened with Switzerland. The goal of AI for Good is to unlock AI's potential to serve humanity. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
All right, so we have with us Tatiana Zaikarenchenko from Lviv, Ukraine, and you will be the first speaker. So I'm Arnaud from the Alice Society moderating this session, and so I give the floor now to Tatiana.
Thank you so much. So I can start, can share the presentation. Yeah, great. So good evening to everyone, or maybe it's good day, depending on your time zone. And today we will be speaking about beyond trade-offs, or how AI can be fairer than we think. And actually all my topic based on our paper, The Possibility of Fairness, Revisiting the Impossibility Theorem in Practice, that we published at ACM Conference on Fairness, Accountability and Transparency in 2023. And at the start of my talk, I will be I will give some details how it was made possible, and then we'll go to the more detailed technical stuff. So this this publication was made possible thanks to a summer internship that became full program that called Responsible AI for Ukraine. This is a fully remote academic research program for Ukrainian students who mentored by leading US and European institutions on the topic of responsible AI. And that was established by the Center for Responsible AI at the Tandon School of Engineering at New York's University in the partnership with my university, Ukrainian Catholic University, that's located in Lviv in actually 2022. So this program is almost 4 years now. And it was established by the idea of Julia Stoyanovich, who is director of this center, and she started from just summer internship and then continued as a whole project, as a whole program. And this program grows every year. And I want to share just a few details about that. That first of all, the goals of this program, they didn't change through years, so we really want to provide a sense of normalcy to Ukrainian students and provide some high-quality research opportunities. That all the most one of the damage that can be as a consequences of the war that is brain leakage, when brain drain, when people move to other countries and especially very qualified people, and we do our best just to keep talented people inside Ukraine and provide the opportunity to do research. And the second goal is just provide mentorship opportunities to graduate students and postdoctoral researchers from all over the world. So if you want to join this program and you have the idea, please welcome, and you can find the details on the link that I provided. And the last, the third one, is just to build research capacity in Ukraine, in the domain of responsible AI. And I guess, like for this all 3 years, we did a lot of work, because we started, for example, in 22 with only 18 research fellows, so it's Ukrainian students. We had only 6 faculty mentors, collaborated with 5 institutions, only 2 countries. That that was USA and the UK, and only 8 projects. And if we talk about today, so now in 2025 we have 49 research fellows, we have 28 faculty mentors, 23 institutions. We work with 10 countries, even with Australia, and we have 21 projects. And just to prove that all the research that we do in this small teams, it's really high quality. We first of all, I want to share that which university work with us. You can see a lot of I can see I can say that all leading university in US and Europe and even Australia. You can see here University of Oxford or University I don't know of London or in Hoven and etc. etc. And the second one, so now we have 18 publications, so accepted papers to top tier conferences like VLDB, NeuroIPS, Nature, and other conferences. And the papers that I will be shared today, the result was exactly as outcomes of this program. And another outcome of this program was establishing of the Center for Data in Society at my university, that we just established, that will be research center that will continue this program, of course, and will have other research that to create not only scientific researches, but also some policies, some solutions for the public good in Ukraine and in other world. And our key areas is responsible AI, of course, data science for education, social resilience and information integrity, and foundation of computational social sciences. So I'm really glad that we started this initiative, and I hope that we will have a lot of international collaborations together, and will continue to build research capacity in Ukraine. So now we can talk about our topic about beyond trade-offs. And what was our background and motivation in this research is that researchers defined dozens of metrics to measure the fairness. So, for example, it could be equalized odds, disparate impact, or any other FNR, FPR, and other metrics. We should understand that anyway, fairness is highly context dependent. It's really philosophical questions, and I always tell teams or students that you need to really brainstorm what is fairness in that exactly situation. Do you have some sensitive categories, for example, and how you can measure this fairness, and how you can measure whether your model, for example, fair. And there are contexts where one may want parity between some groups of several fairness metrics, maybe 2, maybe 3. For example, you can want demographic parity just to balance representation, and in the same moment equal FNR rates, just balance error rates. And there is the impossibility theorem. So if you talk about incompatibilities between metrics, so I can share 3 main results. First of all, the results for Kleinberg that found that Bannon cannot simultaneously equalize calibration with the groups and balance for the positive and negative classes outside of 2 special classes. So when we have equal prevalences, that is in real life, it's really rare and perfect predictions that we almost never have. And then Chudychov actually defined a near equivalent result, really mathematical one. So actually the impossibility theorem for classification, that presents exactly relationship between this like fairness matrix about the predictive positive value, as you see, FPR, FNR, and prevalence. That says if you influence, so if you like have some changes in one, you will have changes in the other metrics. And also, like if you talk about another work about that it was defined like simultaneously, like satisfying equalized odds and demographic parity, like it will be like some metrics will be incompatible. So, but in practice, like it doesn't mean that we apply like exactly that there is in a theory, because like you see like that increasing number of studies in fair ML literature shows that like that in practice we like doesn't need like a really strict result, and we do not seek to ensure exact parity between metrics, and we talk about some approximate solution, so about some margin of error between metrics. And Kleinberg, like he did some stuff, so he did some work and began to investigate like absolute proximate fairness, and but he didn't like explore the space of the solution under this like relaxation of constraints, and he like didn't provide any details like the implications that this relaxation might have like for the practitioners. And like what we did in this paper anyway, like will help with exactly this like thought like experiment that we can think about. For example, we have some racial achievement gap. It's, for example, like for, as you see, for 18, 24 years old competing high schools, and we have for a different race like quite different result. And the question is that with this difference, can we build models for predicting student performance that satisfy like some incompatible fairness metrics that we proved by like this incompatible theorem that it's not possible? Can we have some solution like in practice? So we did it in our paper in two directions. First of all, of course, it's theoretical direction, and we explore some fairness region, so like some where we can have solutions. So the idea was that we can take the impossibility theorem and put there some relaxations for each parameter. So some epsilon for each like matrix that we used. And this will, like, if we don't have like some equation, but we have like this relaxation, so some range that can be like indifference, we can have a space of solutions that actually balance like all these three metrics, and like of course with our desired tolerance. And we call this space of solutions the fairness region. And if we like run some experiments, we will see if we like have some increment, for example, for two metrics like PPV, FNR, and if we go by 0.05, like 0.05, so one like 500ths. So we can see that actually we can have like some feasible model. So every point here is just feasible model that shows that we can have actually like with this relaxation have like the solution. The only problem like that this like not like problem, but this region that we have, of course, it's not like linear, and with some like relationship between them, but still that's why like I show some other experiments. So for example, if we consider some like prevalence in different groups, and we like again we will consider some range of these metrics, we see that if we don't like include this relaxation, we have like some solution. We have solution on the diagonal, of course, like because we talk like that in the like perfect prevalence we have the same in the for both group. We have like ideal situation, and when we have like the more difference we have, the less number of models we can have that like we can consider like fair. But if you put inside this relaxation, so for example, is like to have epsilon like in the range of like absolute value by 0.05, we'll see that we have like 10 times the number of the solutions. So we have like, if we consider like real life, it's like that really make a difference, and that can influence like life of people. What we did also, we like of course we did experiments. So our goal was implement some program that like we consider like of course some this optimization task, like we consider quadratic mixed integer linear program that by the given like data set, and when we have resource constraint, because always, like not always, but in most cases when we talk about some kind of fairness, we talk about some treatment, and this of course this treatment can be like punitive or assistive, but like really like if you talk about about some obvious example, if we have about assistive treatment, so for example we want to provide some scholarships or some support, so usually we have resources that have some constraints, yeah. And of course we have some fairness constraints. We'll talk about this later. So fairness, I mean, we want not like exact, fairness, like, for example, like, I don't know, if you imagine like a division, the scholarship between like women and men, we don't want, for example, if you have like, I don't know, 20 scholarships, have like only 10 for men and 10 for women. Usually we consider some that it's fair to give, for example, 11 for women and 9 for men. So it's still in some kind of fairness window. So, but maybe after like division, for example, 5/15, it's not like considered not fair in this situation. So we have some constraints that like, of course, depends on our fairness metrics that we choose exactly for this situation. Of course, we have some model. We in our paper we used only simple model, like simple classifier, and we have some predictive positive value range. And we ask the question: so does there exist like this set of K observation for which we have like all constraints for fairness, and we choose, of course, if we are in our PPV, like just from Impossibility Theorem, just to explore more, and like this and this solution that do not reduce like the PPV. So we care, of course, about like accuracy of our model. We don't want like to have like bad prediction, and like if there exists some model, so that could like select, we want to build it. So the next step was we build it. Yeah, so I will share like just a little bit more, but which data sets we use to have experiments, and we used our Ukrainian external independent evaluation data sets that I will just a little bit talk about these data sets later. Also, we use really, I guess, well-known data set about two Portuguese schoolwork, Portuguese student performance. Also, 20 Sloan assessment, just not to use all the education, data sets. We also use diabetes risk assessments, and pretty common for people who do like researching for fairness in machine learning. We use fault tables. So about this Ukrainian data set, so we have in Ukraine open data about standardized tests. And we use it like it's a really nice data set because it has like approximately 2.5 million instances. And what is also is really important that we have like sensitive features that we that's why this data set is very nice to use for experiments when you try to understand whether your approach works. And the limitation of this data set is that it's Ukrainian. And of course you need to understand and it has not very nice documentation for it. So for our experiments it was enough, but then we decided, so just go just a little bit from this paper and go to another paper. We decided to make it international, and so did a lot of cleaning and other work. And also, so we published the paper based on this data set in Nature that was called estimating the impact of the Russian invasion of the displacement of graduating high school students in Ukraine. And there you can find this data set. So the link on the GitHub where you can find all the information, really nice documentation, and actually you can use it and especially if you if you work with in the direction of bias and fairness, because the data sets are for this domain is very limited. So so we did a lot of experiments, as you see. So EIE is this is Ukrainian data set, and we have different subjects, and all the subjects have different prevalence. So we consider as a sensitive attribute there gender and territory. It means urban or rural. And thanks to this difference in prevalence and difference in group prevalence, we could see whether we get these solutions with all these constraints and this optimal range samples. It's for different k, and k is here this range from 5 to 20. It means percentage of people to whom we can help and keep it the result inside some fairness window. And we can see that if we have quite large prevalence difference, where so it's much harder to achieve this, to have the solution, for example. And we will see through several other slides continue of this thought. So our algorithm that we have, and you can find on the GitHub, can show that we can build the solution with some fairness constraints. We consider this fairness fairness window, let's call it 20%. So disparity could be from 0.8 to 1.2. Of course, depending on the situations that you have, you can choose different level of disparity. It could be much less if you work, for example, in healthcare, or it could be much larger if you maybe even 1.5, from 0.5 to 1.5, that if you have some flexibility in the domain. So it depends what will be the consequences of your treatment, so of your interactions with the people. And but anyway, you can see that it's quite it works quite very well. And on all 5 data sets, anyways, we found solutions that coincide with our theoretical results. So in theory, we got that we can, with this relaxations, we can have a lot of solutions. And in practice, we actually build the algorithms that can help us show that is possible. Of course, if we just to have some reflection moment and to think about what about our result, that if we have some margin of error that we keep, and we have the size of this the size of fairness region will be affected by at least 4 main factors. So it's doesn't mean that it's all factors, but they have a huge influence. Of course, it's the group prevalence value. Of course, the size of the prevalence difference. Of course, the smaller you have this difference, the better. For sure, the classified performance. So if you have for example, low accuracy, from the start, of course, it's much harder to get this fairness region. And the last is, of course, the size of this resource constraint. So if you the lower the size, the more fair choice you can make actually. And if we return to our thoughts that we sort of experience that we started, yeah. So if we consider that we have different race, yeah, so we have different percentage, yeah, and actually with this base rate difference, it's 10%, and based on that experiment that we built before, with good accuracy, when you have for example at least 75%, we actually can build some models that can be fair with exactly this 3 metrics that we choose, and within this 5% margin of error. Of course, let's again, we choose only these 3 metrics just because we work with the impossibility theorem that told us that in theory, if you took these 3 metrics, so if you want to make your model fair and you will care about 3 metrics simultaneously, it will be not possible to do. And but on the other hand, of course, you can have different metrics that can be more incompatible or less, because you will have some more connections between them. And we work mostly with margin of error of 5%. You can work with quite different, yeah. And in our favor, of course, we use some maybe simple classifier, and of course your model can be much more sophisticated, but still our results give us some really quite optimistic results, because they say that if you put these slight relaxations in our constraints, we can have abundant models. So in practice, consider not some tight situation, but consider this plus minus epsilon that we can have in our model. The second one is that accuracy and fairness are not necessarily in conflict. So of course, any constraints that we put also in our model, we add to our model some constraints in fairness, it influence on the accuracy, but it could be not so large. So of course you can lose some part of the accuracy, but it can be not so critical as keep your model more fairer. So and another moment that, of course, if your model very nice, if you have really nice accuracy, it means that you have more chances to at fairness, because you can lose in accuracy more just to make it fairer. And the third one, that achieving fairness along like multiple metrics or for multiple groups and without sacrificing accuracy is really likely much more attainable than previously believed. Because, when we talk even about really simple example about the scholarship, usually we want several directions keep in mind. I mean, we want to care about different groups. For example, we want to care about gender, or we can like simultaneously care about locations that we want to support. For example, people from rural locations, but we understand, like, because we understand that usually in urban locations we have better education in any country, and if we will support only those who have better education, people from rural will never maybe get like, and we never overcome this difference. And it could be simultaneously like about the race, so that's a question about multiple groups. And the same, you can have like the same like sensitive category, and but you can have like multiple metrics. So our point is that you don't need to choose exactly like keep like protect only one group, or just because of this incompatibility theorem, or protect only one metric. So you don't need to choose. The idea is you can consider several metrics and several groups, but in some like range, in some fairness. If you talk about fairness metrics, in some fairness window, and some like plus minus, exactly like some. Okay, so that's all that I wanted to share today. So maybe there are some questions. And maybe I can provide some more details.
Awesome. Thank you so much, Tatiana, for the interesting presentation. So regarding questions, I think they will come through at some point,
Okay.
if there were any. Exactly.
Maybe
So they will come. So there will be audience questions. Maybe we can, in awaiting the audience questions, maybe I can start off with already one general question, which is,
okay.
how can practitioners decide what margin of error, like the epsilon usually, is appropriate when applying approximate fairness constraints in real world settings for these practitioners? What's your advice on that?
Okay. So great question, and I don't have like easy answer for this. As I told, that like starting from the definition of what is fairness and what is like exactly for every situation, it can be complex. And like, first of all, like the team who works on some decision of the model should discuss like what they want to measure, like which categories they want to protect and how they can measure it. And when people like decide, of course they can talk about this margin of error. And I guess like this epsilon that they can put in the model can be based on the price of the mistake. So price of this like discrimination that we can have like as a result of this model. So your model can be like, for example, that help us to decide like whether to hire a person or not, and the price of the mistake may be not so high. But on the other hand, it could be, for example, as a really famous case of the compass, so models that help us understand whether to release the person like who suspect, who like we suspect this person like that he committed the crime, and the question is whether to release under bail. So and maybe our mistake could be very like not like really have a huge influence on the society, because that we can release a person and he can like kill the other person like on the next day, for example. So the price of the mistake influences this margin of error that we can put. And of course, if we talk about, for example, healthcare, and if we talk about some treatment, so it can be like even have this margin of error less, but it's really context dependent.
Okay, super interesting. Thank you so much for this answer. And also from the audience, from Mariana Romanishin, we have a question. What do you mean by abundant models?
You mean, I mean only abundance, maybe. So we have like a huge amount of like, not really huge, but we like if you consider just remind that slide, if we have this relaxation, for only like 5%, and we get like 10 times number of solutions. So it's 10 times number of models that can work for us. Like that can be like that we can consider as a like fair models, and that like in this like setup that we can use. So that's the idea, maybe.
Okay, great. And then another question. So the questions keep coming in. So could using approximate fairness weaken the protections of sensitive groups by accepting small disparities?
Let's again.
So could using approximate fairness weaken the protections of sensitive groups by accepting small disparities?
Okay, that's okay. That's nice question. Tricky one again. About so if you have like for example, like if you have we decide that we, for example, have some epsilon that we can use like margin of error. And of course, if we have this margin of error, for example, up to 10%, so the trick is, so maybe we can, if it's up to 10%, of course, we want to make models more accurate than fair. So my answer will be yes, true. It could be that like people who develop these models can choose anyway. So like to choose like like the border of this like margin of error, just to keep the model like best performed. So it in some way can weaken like protection of the sensitive groups. That could be.
Okay, yeah, that sounds sensical. And so I think there are no more questions. I don't think, I'm sure. There are no more questions. If you would have any closing remarks, maybe takeaways or future research directions that you say are very important, you can do so now.
Okay, I can continue. Maybe some questions will bump up. So, yeah. As for fairness, I guess a really nice direction in which people can work now is about like proxy. When we, what does it mean? It means that we have now like several laws or any other like legislation of the discrimination of people that we can see exactly. For example, we see that we have like information about the gender inside, and we can catch this discrimination. But really, like we have a lot of situations when we don't have like this sensitive information, but still we have discrimination. It's just because like when you have some information, for example, from other categories, it can be like your address, or it can be what you finished, and what you finished can describe, like for example, your gender identify. So you can collect this, like the model can collect this information and make some model, for example, that will discriminate the person by gender or by age, but you didn't put like exactly this information. So we called it proxy. So when we collect this information from other, and that's very nice direction for research, both like from technical perspective, how we can measure it, and see how we can see like, do we have like this proxy capacity, and do we have like actually this proxy use, so whether this model actually discriminate on this like approach. And another, of course, it's a really nice direction for people who work with legislation, because it's really easy like to write how we can like describe at least about discrimination by some categories that we actually see, and it's quite hard to describe how not discriminate by some categories that we can see. So I guess like that's one of the most interesting like directions that I saw. Yeah, so yeah,
Yeah,
I
so
see you.
actually, yeah, so that's
Yeah.
great. And also, so regarding this legislation and regulation, like we have one question from the audience from Alan Lee. How these findings, what do they mean for regulation on a global scale for utilizing AI across various industries?
About that proxy that I told, or like the previous, or we
In
don't
general,
know.
in general, the findings of the talk. Yeah.
That's good. That's good. Okay, so I will tell about like this. If we like talk about the previous, like all my talks that when we have exactly some sensitive categories that we protect by law. So for legislation, it's good question just to consider this like like I will tell in this. So I'm like a mathematician. I always want to, some measurement. So if I read so that you don't you can't discriminate. That means that you should treat like equally people from one group and for another group. For me, it's like what is equally, and for like for the world, I guess, for people who work in legislation, the topic that I opened today, like for practitioners, it says that we should consider what is equally and what we can consider like equally in some in which approximation. Yeah. So about this discrimination. So it's some kind of uh, approximate equally. Yeah, so it maybe we can make like these laws better that can uh, give some space for people who work with models, so they can create actually fair models that like under like law they are not discriminative, but like if we like have this approximation equality, and they have like more possibility to create these models. So I guess like everybody will win after that. So that one direction with that we can work, and another about this proxy. So again, we should start like to investigate more on the technical side, and once we will have the answer, because now it's like it's under research. There are some nice papers about that, but still we have like a lot of to do from the technical side, and see which solutions we can have, and based on these solutions, like possible or some like solutions, experiments, and etc., we can go to the people who work with law, like with legislation, and maybe have like some other constraints, like not so good for people who work in IT, but anyway, it can help people who live in a real life and have the influence of this model. And we all have the influence because we all, like we all use, I don't know, like social media with models that like. Suggest something, or we can apply for the job, and some model like decided whether like to ask like invite us for the next level of recruitment and other. So we have the influence. Yeah.
Okay, nice. I think that's also a nice closing of yeah, of this session. So it was great having you. Thank you so much for speaking. Also, you are a member of the Alice network. I mean, Thanks also ITU for hosting this AI for Good webinar. And we're very happy to have you as a member of the ALICE, European Laboratory of Learning and Intelligent Systems across the European continent and beyond.
Thank you so much. And I hope with our like newly established Center for Data and Society, we will have like more collaborations with ALICE unit.
Yeah, the
Yeah,
ALICE unit or the associated ALICE unit Lviv, right? So
yeah,
that's
that's
now
true.
also part of the bigger ALICE network. That
So,
was so happy to include you and co-supervision and exchange and research exchange to make the world a better place through science.
yeah, that's true. We are so happy like that we joined to your community and we just start, like to explore all possibilities that you provide. And like,
Okay,
yeah,
good.
thank you.
That is the ending of our session. And then I thank the audience as well, although we cannot see them. We know there's quite some people watching. And yeah, then until next time.
Yeah, thank you so much.
Bye, everyone.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.